Hello everyone, welcome to the TechnoGate. So here we will discuss how to decide the time complexity. What is the time complexity for the particular program? Okay. So here first one is the main int x y z x equals to y plus z. So these are the statements here. So statement execution only once in its lifetime. Only executed only one time here. So here one time. Here again statement one time. So what is the total here? Two times. So this statement will execute it two times only. One time this one and one time second one here. So two times here means constant time it will take. So in terms of algorithm, how to decide the constant time here? Order of one. Order of one. Yeah. So constant means not like a one time execution. It means suppose that if you are giving the input like x equals to 5, the number of steps are taken by like suppose 10. Again, if you give the input again 10, again number of steps are same, y equals to 10. Y is the number of steps, okay. Suppose x equals to 100, again same number of steps here. So every time for the different inputs, we are getting same number of steps. This means constant, means order of one. Constant time it will take. Okay. So this program time complexity is the constant here. Next one is this one. So again, statement here, only one time execution here. Again this is statement, one time execution here. So this is a for loop. Okay, this is the for loop here. So for I value 1, it executes one time, I value 2, 2 times, I value 3, 3 times. So it goes to the n times. So this statement will executed n times here. So n times here. So what is the total time here? N plus 2 times. N plus 2 times here. Okay. So here, what is the time complexity of this program here? So here, what is the variable here? N. Suppose that, so this expression will changes when we update the value of n, or we changes the value of n. Suppose that n is 100, so 100 plus 2 is 102. Suppose n is 1000, 1000 plus 2, 1002. Suppose n is 10,000, then 10,000 plus 2, 10,002. So every time this expression changes because of the value of n, because n is a variable here. So time complexity depends on the variable. How much time it will take, we will update the any variable. Okay. So here, what is the higher order term here? Or we can say higher order term always with the time complexity here. So what is the higher order here? Here linear here. Here 2 is constant here. So constant and linear, which one is bigger? Is a n. So is a order of n. So time complexity is order of n. So whenever we ask the what is the time, so we can use any one of the notations here, like big order of n here, big of n here, omega of n here, and theta of n here. We can use any one of the notation whenever we ask the time complexity. But suppose that they ask about the worst case time complexity or maximum time, so then we always use the big O. So big O notation we use the for the maximum time. For the maximum time. Okay. We will discuss in the upcoming lecture. What is the best case time complexity? Then omega of n is a minimum time or best time. What is the average case time? Then theta of n we will use for the average. But only time, then we can use any notation. So remember this one. Okay. So these are the two programs. So here constant time complexity here and time complexity here. Suppose that we will take one more example here. So the next one is the main program here. Okay. So I1 to n for j1 to n, and here x equals to y plus z. So this close here, this close here, this close here, this close. So what is the time complexity of this program? Okay. So here again is the statement here. So there is a no role of k here. So remove this one. So here again one time statement execution only once here. Okay. Then here this is 4 loops and this 4 loop is closes here. Okay. So here maximum value of n. So this statement will executed n time only. So this is the n time here. And here I value 1 year. I value 1 year. It goes to the n time. So for particular value of I, the inner for loop will goes to the n time. I value 1 is go to the n time. So what is the maximum value of this for loop? N here. So for n, this goes to the n into n square time. So what is the maximum time here? Here n square. Because these are nested for loop here inside 4. So what is the total time here? N square plus n plus 1 here. Okay. So what is the maximum or bigger function is there here? What? N square. So time complexity depends on the bigger function. So what is the time complexity here? Order of n square. So in this way we can conclude the time complexity of a particular program here. Okay. So now next one is, suppose that so here main function is there. Okay. Int x, y, z, and here okay. While n greater than equals to 1, n equals to n by 2. So this is the program. So in this program, what is the time complexity here? In this program, what is the time complexity here? So let's see this one here. So write one more statement here, like x equals to y plus z. Okay. So here again, here one time execution here, and this is a while loop here. So suppose that, so in this program, how we check what is the time complexity? Suppose that we will take n is 16 here, n is 16 here. So 16 greater than equals to 1 executed, then n becomes n by 2 here. So now n becomes 8 here. N by 2, 16 by 2, 8 here. Again 8 greater than equals to 1 okay, because of while loop here. So it runs many times whenever n greater than equals to 1 here. So n is 4 here, because n equals to n by 2 here. So 8 greater than equals to 1, then it becomes half. Now 4 greater than 1 again executed, then n becomes 2 here. Okay. And now 2 by 2 n becomes 1 here, then it will execute here. Okay. So how many times it will execute here? Here 1, 2, 3 and 4 times it will execute here. Okay. So n value is 16, it execute only 16 times. Okay. Suppose that if we take like n is 1000 here, n is 1000 here. So 1000 then equals to 1 here, it will execute and becomes 500. 1000 by 2, 500 here. Again executed and becomes 250, execute, and becomes 125, execute. Again 125 greater than equals to 1 execute and becomes 62 here. Okay. Now again 62 greater than n becomes 31 here. Now n becomes 15 here. Now n becomes 7 here. Now n becomes 3 here. And now n becomes 2 here. So how many times it will executed? 4000 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times here. Okay. So approximated how much time it will take? Log n time. Logarithmic time. So how much time is logarithmic time? Logarithmic time. So here suppose that we put the value of n here. So n value is 16 here. So 16 means 2 raised to power 4 here. So it becomes 1 here, logarithmic property here. So it is 4 times only. And it approximated log 1000 times here. So whenever we see the division and multiplication in the while loop, time complexity always in the logarithmic terms. So what is the complexity here? Log n. So n is 16 here. 1, 2, 3, 4 times it will execute. So whenever see the division, this is division or multiplication in the any loop, like while loop, for loop or do while loop, time complexity always in the logarithmic terms. Okay, so through this approach, we can calculate the time complexity here. So we will say one more problem. Okay, so this is one of the gate problem here. So suppose that this is one of the gate problem. A is a function, any function is an, okay, and this is a while one and printf hello. Suppose this is a program. So what is the time complexity of this program here? So while one means true, so any value other than 0, while loop always gives a true. Only in case of 0 it returns the false here. So every time it is 1, it is a true. Okay, because so it gives the infinite loop. So it will execute it infinite times. It will execute it infinite times here. But what is the property of the algorithm? First property of the algorithm is it should take finite time. So time complexity exists only for the finite programs, not on the infinite programs. So it is an infinite loop here. So what is this here? What is the conclusion here? So conclusion here, time complexity does not exist here. Does not exist. Because time complexity exists only for the finite program. Okay, but this is an infinite program, so time complexity does not exist. So time complexity exists only for the finite number of the programs, not for the infinite number of the programs. Okay, thank you everyone. So we will discuss more of the time complexity problems in the upcoming lecture.